everyone is eager
Yeah.
to learn what we have in the session today. So over to you, Saurav. I think we are now good to go. More people are joining in, but I think we can start in 1 more minute.
Okay, yeah, sure, sure.
Yeah. In the meantime, you guys can drop in the chat box what all personas you have, what all profiles you currently have, what kind of roles you're coming from, and we'll have the idea on what kind of audience today we have for the session. Nice, awesome. We have very good, you know, kind of audience we have today, so it's going to be awesome. Over to you, Saurav.
Hey, thanks, Anshik. Hey, folks. Hello, everyone. My name is Saurav Prateek. I'm a web solutions engineer at Google. And yeah, this session will be on building a basic chatbot web application. So we'll be doing a code walkthrough probably. And whatever we'll be building, we will be using LangChain framework. So this is a new framework actually, which provides some abstraction on top of the LLM models. So the concept is that we build nodes and connect them with edges. And us as a developer have the authority to build business logic or decide the control flow on how the LLM can function, or if LLM responds with the in control, right? So that's what we are gonna do. Okay, so first, like beforehand, anyone has used LangChain before? If if anyone have, like, just give me a yes in the comments. That would be helpful. I just wanted to understand like how many of you are familiar with the framework. Okay, it's a new, so I'm not expecting a lot of people being familiar actually. If it's a yes, then okay, Akhil is familiar. Great, awesome. Okay, cool, no worries. Just to set the expectations straight, so this LangChain framework can be implemented in multiple programming languages. For the sake of today's session, we will be using TypeScript. So will be whatever development or implementation we'll be doing, that will be done in TypeScript. So just anyone has used TypeScript before? I feel a lot of you have done that before. So TypeScript or JavaScript, both would be fine. Even if you have a basic understanding of JavaScript, it should be okay. Little JS, Angular, okay, Python. Okay, so what I have done is that I built a Node application here, and within Node, I have used TypeScript as a language to write my business logic. Okay, in Python, I know only Python. No worries. We will be like not going into that much internals of a language. We'll be talking at a logic level. So uh, even though you have seen this in TypeScript, you might be able to do that in implement in Python as well. So yeah, let's start without wasting any much time. Okay, so first we'll see what is LangChain and LangGraph. Just to give you a little bit of introduction, LangChain is a new framework which has been recently launched, and it has been lots and lots into talking. They have their YouTube channel where they used to post a lot of tutorials on how to build agentic LLM applications and multi-agent workflows. So what LangChain helps is that they helps us to build agents and connect with them and decide the control flow. And LangGraph is another framework which has been provided by LangChain that helps us to do that. So if you want to build multi-agent workflows, then LangGraph is, you can try it on LangGraph actually. LangGraph, if you go through their GitHub repo and their YouTube channel, you will find this, that you can implement this particular framework in multiple programming languages. It can be Python, it can be TypeScript, it can be other languages as well. So Python and TypeScript has been, like, Python has been a lot in popular. I have seen them also like giving the code walkthroughs in Python. And yeah, so moving forward, we'll be building this chat application in LangGraph. So it is important to first understand what LangGraph is, right? So again, LangGraph is a framework provided by LangChain, and LangGraph is a framework which is responsible for building multi-actor application. So basically, if you want to build workflow where you are interacting with different LLMs, so suppose for a particular use case, you are interacting with one LLM model, and for your different use case or another use case, you are interacting with another LLM model, then LangGraph helps you to achieve that. You can have multiple different LLM models into your workflow, and you can interact with them, and you can decide what should be your control flow looks like, right? So that's what LangGraph is all about. How does LangGraph do that? So basically, LangGraph achieves this by the help of its graph architecture. So I guess anyone you have previously learned graph and data structures and algorithms, right? So a lot of concepts which you have learned there will help you. So again, the graph is basically a combination of nodes and edges, where nodes are connected via edges, and the control flow goes from nodes to nodes where they are connected with different edges. So same concept in LangGraph as well. They have the concepts of nodes and edges, and by coding or implementing nodes and connecting them via edges, you build the workflow. So that's how the workflow looks like. In the right hand side, I have this can be one LangGraph workflow, where you can see the first node is building a vector store, and then after that it is connecting, the edge is connected to another node where it is generating the answer from the rack framework, and so forth and so on. So this can be one of the examples. We're going to see how we can actually build a workflow like this, where we will be coding a lot of nodes and we'll be connecting with them. What is LLM? Okay, so LLM are actually large language models. They are generative framework. So basically, what they can do is that they can generate new content, right? That is the in the most basic shell, that is what LLMs are. So you can ask question, you can tell them to summarize something, you can maybe take some inputs from them. They can generate different content for you in the text format, in the image format, in the video format, right? For now, we will be like in this lecture, we'll be looking at the LLM which generates content in text format. We will be using an LLM which generates content in image format. So basically, what we will be doing is that of OpenAI, that is probably till now is saying they are. Or is it audible? Your voice or network issue maybe. Okay. Is it clear now? Okay. Okay. Am I? Okay. I am getting past. Okay. Someone is saying now clear. So I can switch off my video so that we can increase, like, we can get the better performance. So if that is okay. Okay. Am I audible again? I got just disconnected. Okay. Okay. Is my screen visible? I have switched off the video.
It is visible. The screen is visible, but
Audio.
you know, I mean, the presentation is visible, obviously, and your voice is fine too, but we cannot see.
Okay.
Yeah.
Okay. But I have purposely switched off the audio video so that I can like deliver it.
Okay.
I guess there is some network issues
Okay.
from
Okay.
my
Sure. 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 You can continue.
content. Okay. Okay. Cool. Let's. Yeah. So till now, is the agenda clear, or like is there any issue in the concepts which I have explained? So everyone like got the idea what LangGraph is, what nodes are, and what edges are. So in summary, what we are doing is that we'll be building a chat application, a chat web application in LangGraph using nodes and edges. And okay, could you give a, yeah, that's good. That's good. Yeah, please ask questions that will help me to understand where I have, like where my audio broke. So yeah, giving the concept, you must have like a heard of graph data structure before as well. It is very similar. So as in graph, there were nodes and edges, where nodes were connected with edges. In the same way, here as well in the LangGraph framework, we have nodes which are connected by edges, and we will be coding the nodes so that we can like have a business logic, right? So let's move forward. We will try to understand what we are trying to build here. So these are the basic LangGraph concepts. So what we are doing is that we'll discuss the concepts. What are the concepts here? The first thing is internal shared state. So what is an internal shared state in LangGraph? Basically, when a graph is executed, there is a state which we initially create, and that needs to be passed to different nodes, and that's why it is called a shared state, because that is like being shared by different nodes, and nodes can manipulate that state. So suppose if I get a particular state, within that state I have an information, and I can modify that information, and I can pass that information or the state to the other nodes, and other nodes will see the modification done by me. So it's a kind of a communication channel where one node can make some modification and pass it to the other node, and other nodes can see that modification, that what has been done by the previous node. So that is the concept of internal shared state, right? The second thing is the nodes. So nodes are basically independent agents, right, that perform a unit of work. So every node has a business logic incorporated within them. So every node is, so whatever business logic we have, we put that in our node, and the node performs that. And then whatever the node has done, at the end it changes the state of the shared state of the graph, so that another node can be communicated. And edges are simple, they can connect two nodes with each other, so that the control flow can happen, right? Edges helps us to decide that when one node is executed, what we have to do after that. So that is the LangGraph concept. So basically, we need to understand the three things. Another, the fourth thing is the conditional edges, which will come up in the next slide. So are these three topics clear? If yes, then give me a yes. If there is a doubt, then you can just like ping that in the comments. Okay, cool. Great, great. Okay. Another thing is the conditional edges. So in the conditional edges, it is very similar to a normal edge. The only difference is that a single edge can direct a node to another node, but conditional edge has the power to decide which nodes or which direction the flow should go to. So every conditional edges decides the execution of the control flow on the basis of a decision. So on the right hand side, I have one example of a conditional edge, which is checking basically if we have some relevant documents or not. If we have a relevant document, then it is generating the answer. If we don't have a relevant document, then it is ending the execution. That is the whole concept of conditional edges. So as the name suggests, they have some conditions implemented into it, which on the basis of that, they can decide which way we have to go, right? That is the like high level idea of a conditional edge. And we will be implementing a conditional edge in this session. So is this clear? Okay, I guess it is clear. Okay, cool. So what we are trying to build here, we are trying to build a chatbot web application. So the first thing we'll have to do is that what the application will be all about. So what I'm doing is that I'm training my LLM model on the basis of software engineering and coding interview content. So I have like created a lot of software engineering and coding interview related content. What I have done is I have picked up that content in a text format, and I have given it to the knowledge base. So knowledge base is basically an external vector store. I have put the content into it, and then I am grounding my LLM model on the basis of that external knowledge base. And once the LLM model is grounded, I am asking question related to that. So basically, I am saying an LLM model that, hey, this is the context for your software, for a software engineering coding interviews. Just go through it, and after that, I'm going to ask you some question related to that. Just answer me accordingly. And here we have a catch. So I am designing my chatbot in a way that if I'm asking question related to software engineering and coding interviews, then it will try to answer it. But if I'm asking anything random, so suppose if I ask my LM model that, hey, what's the weather? Or like, can you make a cup of coffee? Some questions like that, which is completely irrelevant to software engineering and coding interviews, then it will respond with, I don't have any answer. So there we will be using the LangGraph to direct the control flow. So if we are asking question which is irrelevant, then it will straight away say that I don't have any idea about it, or whatever you are asking is irrelevant to the topic or data on which I'm trained upon. right? So Bhavesh Kumar is asking what is LM model? Again, LM models. So uh, these are large language models. They are like what they do is that they generate content for you. So whatever they have trained on lots of data, on the basis of that, they are able to generate a lot of content and relevant content. You can ask question, you can tell them to summarize something and a lot of things. Okay, is that clear what we are trying to do here? Now we are moving to the final implementations. So okay, again, voice is break. If I'm like, I'm not, was the previous slide? Okay, just okay. Let me know if I'm audible now. I have
You're
tried to
audible,
switch my
but your
location so
screen
that
is
there
not
can be a better.
visible.
Yeah, yeah. I'll just share. Give me a minute. Okay, apologies for this. I was not actually expecting this kind of network lag, but yeah. Anyways, so I hope we don't lag anymore now. So yeah, let's start. So this is the architecture of the chatbot web application we are planning to build. We will be starting with creating a model, and then we will be creating our question. So whatever question yeah, we are going to build the entire chatbot. Yeah, no worries, it's all over. Yeah, I guess the same. So yeah, we will be creating the question, and if the question is relevant, or if you're asking a relevant question related to software engineering and coding interviews, then we will gonna go ahead and we're gonna retrieve our content which we have stored in the vector store. Then we will check we have retrieve relevant content or not. If we have retrieved relevant content and if the question was also relevant, then we will ask our LLM to generate the answer. If not, if the question is not relevant or the if we don't have a relevant document, then we will gonna exit with exception will gonna give us an exception message, whatever we like to say. Do we have any human query? Do we know any human queries outside scope of knowledge vector? Okay, I'm not able to get this question correctly, but yeah, let's move ahead. We don't have much time. So the first thing is that I previously explained what a shared state is. So this is what a shared state looks like in TypeScript. So it's a basically a class or an interface where we have the fields which we want to share across multiple nodes. So since we are building a chatbot, we will have question, generated answer, documents, and model. So question is basically the human question which we will be asking. Generated answer will be the answer which LLM model will generate for us. Documents will be basically the relevant document which we will be pulling from the vector store. So remember, in the vector store, we are storing our knowledge base, whatever knowledge base we have for our software engineering and coding interviews. And we will gonna retrieve that from the vector store and we will store that in the documents because we have to give that document to the LLM model. And this is the model. So this will be shared across all the nodes. This is an OpenAI LLM model which we're gonna create. And then we will gonna build our entire chatbot using this interface. Okay, is that clear? I hope we are not getting any more lags, audio lags. If this is clear, just give me a yes so that I can like confirm from my end as well that we don't have audio lag. Okay, I got a yes. I think we don't have a lag. Okay, cool. Thank you, folks. Thank you. Thanks a lot. That means a lot. Okay, cool. Do we have models? So yes, we have models for Python and Java. It depends upon you. Whatever, like LangGraph can be implemented in Python as well, so you can do the implementation in Python too. All clear? Please proceed. Cool. Okay, let's create the first model. So as far what we have seen, everything is in TypeScript, right? So what a node looks like, this is what a node looks like. So this is a create model node. You have seen here the first node is create model in the graph structure. This is what we are building here. First, our first node, create model. So create model, what we are doing is that we are taking the state as an input, and then we are creating a model. So it's basically a new OpenAI model with temperature. OpenAI key is paid. Yes, OpenAI key is paid. You have to buy it with some credits. There are some more open source local LM models as well, which you can install in your machine and try that out too. But for here, for the ease of the lecture, I'm using an OpenAI model. I'm specifying the temperature. So temperature basically tells the model that how varying the answer can be. I'm here specifying temperature 0, meaning that I only want the answer which is completely or highly relevant. I don't want low relevant answers or moderately relevant answers here. And then I'm returning the model. So what I'm doing is that I'm creating a model, and then I'm saving this model in my shared state. So from here on, uh, the nodes which are ahead of the create model will get the OpenAI model which is already created by this. So that's what a node does here. Okay. Let's create the second node. So again, if we go back to our structure, we have gone through the create model, then we will check how to grade a question, right? We are passing a question into our shared state. We will see how grade question looks like. So again, in the create model, we have already created our OpenAI model. Now here, what we are doing is that we are creating a question, meaning we are deciding whether our question is relevant to the software engineering content or not, right? So how you do that actually? So in order to do that, you have to tell your model that what you are planning to do. So here, and how you do that? You do that by using prompts, right? So prompts are a way to tell the model that, hey, I am trying to do this thing and give me this answer. And then model tries to understand that, okay, you're trying to do this. I have to perform this operation. I have to perform this option. Send the prompt to the LLM model. Here in the pipe state.model. This is the model which we have created in the OpenAI. In the create model node, right? And that was passed in the shared state. So now you see how shared state is helping, or how we are sharing multiple um, information through the through this. Okay, so again, I'm gonna repeat that. So we have created our yeah, I'm gonna repeat. So we have created our LLM model previously in the previous node here. We have put that in the shared state in the return. Okay. Now what we are doing is that we are using that shared state model here. Whatever model OpenAI model we have created previously, we are using it here, right? That is the question grader. So we are passing the grader template into the model, and model so that model can understand what you have to do, and then we are passing the question as well. So how our grader template looks like? It looks like this. So this is our question grader template. It says you are a grader assessing the relevance of a question to the topic related to software engineering and coding interviews. Here is the question for you to assess, and this is the question actually. In the curly braces question, we can pass our actual question from the variable. So this is a placeholder. This will be filled when we will be passing the actual question. If the question is not relevant to software engineering and coding interview domain, return with an exit response. Otherwise, return continue. So when you give this grader template to the LLM model, the model will understand that, okay, according to this template, I'm gonna get the question. So here in the question grader, we are passing the question here, which for the placeholder we have kept in the template, right? We are we are replacing that placeholder with our actual question that is present in the shared state. So in the question, we are passing the actual shared state question or whatever question we have asked, and then the model will gonna have full context that, okay, this is the question and I have to grade this question, that whether this question is relevant or not on the basis of software engineering coding interviews. If it is non-relevant, then I have to return with an exit word. If it is relevant, then I have to return continue, right? And in this way we will get the final response in the grader response. Now grader response will be a string. So what we will do, for the sake of uh, avoiding uppercase and lowercase issue, we will be transforming the greater response to a lowercase. And then we will check whether the word exit is there or not. If the exit word is there, then we will replace the answer should be so that the node which is ahead of this can understand that okay, the question which has been asked is was not relevant, so we have to exit. That's what we are doing here. So is this grader question node clear? This is a bit in detail. So okay, good, great, yes, nice. Okay, I got it. First, can you please explain it again very briefly? Okay, good. So uh, okay, if I say briefly, what I am doing is that I am uh, telling my LM model that what they have to do through prompt. Within the prompt, I have my explanation ready. Ki, hey model, you have to assess my question on the basis of software engineering coding interview. If the question seems to be relevant, then return with an exit response. Otherwise, return continue. That's what we are doing. Then we are checking the response. If the response is exit, then we are replacing our answer, generated answer with exit, and we are returning the state. That's what we are doing. What does the grader function do? Grader function basically grade the question. So if you will ask an LM model that, hey, what is the what can you make a cup of coffee? Then grader question will gonna grade and LM model will say that, hey, this question is not relevant to software engineering and coding interview, and I don't have to answer it. And it will return with an exit. I hope that is clear. This is a very elegant way to control your responses of the LM model and control their functionality. Okay, should we move ahead? Cool. Let's quickly move to the next node. Again, the next node is retrieve relevant document. So again, I'm gonna go back to the node structure with after grading the question. If the question was relevant, then we go ahead and we retrieve our context. So here, giving you some context, what we are doing, retrieving the relevant document. Now, we are retrieving our relevant document from the vector store. Initially, what we have done is that we have created a vector store. Within, we have stored our knowledge base. So whatever content I have, so suppose you have a content in PDF or you have content in URL, you can pull their text and you can store that in the vector store. Now what I'm doing is that from the vector store, I am retrieving the documents on the basis of the question asked. So if you are asking the question that, hey, like, tell me how to clear my coding interviews, or tell me how a data structure and algorithms interview looks like, or what is system design interview. So whatever the question you are asking, it will try to give you some relevant documents from the vector store so that you can further move it to the LLM model, or you can further pass it to the LLM model so that LLM model can answer your question on the basis of that context, right? So that's what we are doing. Once we get the relevant document or once we get some relevant document, we are storing that relevant document here, right? Now, again, this is a shared state. So what we are doing is that we are updating the document field of the shared state from the retrieve docs so that when the control flow moves ahead, the node ahead of this we can get the retrieve document from the shared state itself. That is the concept of the shared state. What is const here? Is it variable? Yeah, it is a variable. Okay, is this clear? The retrieve docs, it's barely a 3-line code. So I think it should be clear. If not, just let me know. How do we build the vector? That's a good question, actually. What is the vector store? It's a quite complex one. I can walk you through the code base, but at the end of this session, like when we have covered this entire logic. So just keep in mind, we have to look into the vector store code base. It's a very small code base. It's a 12 to 13 line method. I'm gonna walk you through. But apart from that, is everything clear? Just let me know so that we can move ahead to the further notes. Okay. Okay, I think we are good. We can move ahead. Cool. So this is another node which grade the retrieve document. So whatever document we have retrieved, I would have loved to explain the first and second step, but yeah, bear with me. I have like little time and we have to complete this episode. In the previous node, we have retrieved the relevant documents, right? So here what we will do is that we're gonna grade those relevant documents. So we're gonna see that whatever document we have got from the vector store, are those relevant to the question we are asking or not? Now, if any document is not relevant, or if the vector store has returned some irrelevant document, which is not at all related to the question, then we will gonna filter them out here, right? Now, before moving on to this piece, I would like to convey some message, right? So based on my experience, if you're planning for a career transition, it's crucial to upskill and have a solid roadmap. So it is important for you to save time and get the right mentorship. So I highly recommend you folks to investing in a paid program that helps you build your profile from scratch, right? So experts like myself are available to teach you during that program. And it's fine if you want to go ahead and self-study, but in times like these, it's really important to have a tailored role. So if you want to understand how a paid program can help you fasten your career transition, you can fill the form. And you can get a chance to connect with the Coding Ninjas program expert. So Coding Ninjas team in next like a couple of minutes, they'll explain about the full stack web development 9 months job bootcamp that offers comprehensive training and placement assistance till you land your first job after the completion of the course. Right? Okay, that was it. We can resume our session again now. Okay, so grading the relevant retrieve document. So what we were doing is that previously we pulled some document from the vector store. Now we want to understand that whatever document we have, is it relevant to the question or not? So that's what we are doing here. Now look at this very carefully. So the first line is we are uh, storing the docs. This is nothing but whatever we have in the shared state. And remember, in the shared state here, we have initialized the documents with the retrieve documents, or basically the documents we retrieve from the vector store. So this is the document which we are storing here, and this is basically the collection of documents. So we are iterating through this list of documents. For every document in the list, we are checking whether the document is relevant to the question or not. In a very similar way, we graded the question previously in the previous one. In that way, we will again grade the document, but this time we will grade the document on the basis of context. So we will have a separate template, right? Prompt template, which will give us to the LLM model. Along with the template, we will pass the question and the document so that LLM model can understand that, hey, this is the document and this is the question. And then I have to check whether this question is relevant to the document or whether the document is relevant to the question or not. If the document is relevant to the question, then the model will return yes. If the document is not relevant to the question, the LLM model will return no. And that's what we have done here. If the greater response which we got is yes, it means that we have a relevant document. Then we have pushed this relevant document into the relevant document list, which we have initialized earlier. And after that, again, what we have done in the shared state, we have updated our documents with the relevant documents so that the nodes which are ahead can get the relevant document which we have filtered here in this node. Now, I understand you must be wondering what this data template is. So this is what the template for this particular node looks like. It's very simple. You are a grader assessing the relevance of a retrieve document to a user question. Here is the retrieve document. Within the content, we are storing the retrieve document. And here is the user question. Within question, we are storing user question. Now, if the document contains keyword related to the user question, grade it as relevant. If it does not need to be stringent test, the goal is to filter out the erroneous retrievals. Now give a binary score of yes or no to indicate whether the document is relevant to the question or not. That was the entire grader template. Now you will see we have the placeholder for question and content. That's what we are filling here. In content, we have stored the document, which we retrieved from the vector store. And in the question, we stored the question which we have asked or we are planning to ask to our chatbot. So is this node look yes in the comments? Yeah, I can show the grader template. So the grader template is pulled by the LM model and then we grade yes, exactly. So that's an LM model. And especially that OpenAI model has a lot of things. It has been trained a lot of things. So it will not understand what you're trying to do until unless you tell it properly. And that's where the prompt comes up. So you by specifying the prompt, you specifically tell the LM model that what they have to do, and then you pass on some variables to support your prompt. So here, for example, we have passed the content or the retrieved document from the vector stored in the content and the question as a question so that the LM model can get the full picture what you have been asking to. So there's a new kind of programming actually. So earlier what we used to do is that we used to write simple logics to program, but here what we are doing is that along with writing some logic, we are using LM models wherever we can, and we are utilizing their capability to get things done. Which platform is best to develop chatbot? Okay, that's not a relevant question. Let's just let me know if the document grader uh, node looks clear to you, folks, so that we can move ahead to the next nodes. Okay, got it, Vishal. I'll do that. You want me to explain the first and second. Just ping me when we are done with the chatbot uh, session. Then I can spend some 1 or 2 minutes to explain the first and second step. Okay, I think a lot of people are okay. I may yes, so that I can
Hey, Saurav Prateek is looking into it. Oh, there is some problem with his network today. Please stay with us for just a minute. He'll be back.
voice audible. I was not able to. Okay. Is there anyone from the moderator here? So anyone can confirm if my voice is audible.
Yes, yes, it's there. Yeah, we can see your screen.
Okay, sure. Thanks. So yeah, folks, we were there generating the answer from the LM model. So before that, was the document grader node clear? Just give me a yes if it was, then I'll go move ahead to the generate answer. Okay. Okay, cool. Cool. So generating the answer. So what we can do is that we had our question previously. We graded our question on the basis of whether it is relevant to the software engineering coding interview content or not. And we saw that if it was relevant, then we moved ahead and then we pulled the document from the vector store. And then we saw whether our document, which we have pulled from the vector store, is relevant with the question we asked or not. And then we filtered out those documents. If any document was not relevant, then we filtered them out. We only picked the relevant document. And then now since we have our relevant document and we have our question, we are moving to generate the answer. So this is a basic uh, we are giving it a rank. We are basically sending a rank prompt here. What we are doing is that we are giving the context and the question to the LM model, and we are asking it to generate the answer. So what it does is that in the context, we are passing the documents which we have retrieved. In the question, we have passed the question which we have asked, and by this, we are generating the answer. So this is a very small node, which basically, because we have already done the heavy lifting before. So RAG is retrieval augmented generation. When you ground your LLM model on the basis of external knowledge base, the way we have done here. We are not using LM model directly. We are first grounding it on the content which we have, that is our software engineering and coding interview content. And then we are asking the question relevant to that content. And that is basically called RAG. So what we have done here is that we have practically built our in-house RAG, right? So we have done our heavy lifting before already. Since we have done our heavy lifting, we have our context, basically the relevant documents, and we have our question. So RAG is relevant, oh sorry, retrieval augmented generation. You can like Google it. It's a quite um, familiar or quite hot topic currently. So yeah, in the context, we have our retrieve documents. In the question, we have the question which our user or we are asking, and then the LLM model will generate the answer. And that is the final answer which we are generating here. That will be returned by the web application. Is this node clear? If it is, you can give me a yes. Okay, great. So we have uh, built a lot of nodes here. Now it's time to connect them to build a graph. So here you see our create model node. That is the first node which we talked about. Then we have our grade question that creates a question on the basis of whether it's relevant to software engineering interview or coding interviews or not. Then we have our retrieve node, which basically retrieve the documents from the vector store. After that, we have our grade document or document grader node, which grades the document retrieve from the vector store. Basically, it filter out those documents which are not relevant to software engineering and coding interview topic. And then we have an exit with exception. So if at any point of time, if suppose if while when we were grading the question was not relevant to software engineering and coding interviews, then we directly exit with exception. If the document which we have graded here is not relevant to the question, then also we exit with exception. If all of them are a yes, then we go ahead and generate from the model and then we end the graph. Does the order of adding edges matter? Order of adding node does not matter, but order of adding edges matter because if you see, I'm not only adding edges, I'm connecting two nodes here. So in the first line, add edge, start create model, I'm specifying that I want to start my graph by creating the model. After that, after when I am done with creating the model, I want to grade my question. That's why I have added the another edge, create model to grade question. After that, I am adding a conditional edge. That is, once we grade the question, you remember we can basically grade question, specify whether the question is relevant or not. That output goes into the conditional edge that is called can continue. And this can continue returns a yes or no. If we can continue returns a yes, basically that it means that we can continue. Then we move ahead with, we go to the retrieve node that will basically retrieve the document from the vector store. If it says no, basically if can continue says no, then we it means that we cannot continue. It means we exit with exception. So can continue implementation we will see ahead. After that, I have added an edge from retrieve. So once we have retrieved the document, we will grade the document. After again we are adding a conditional edge. Once we have graded the document, we see that whether after grading the document, do we have some relevant documents left or not? If we have relevant document left, it means we can generate. So we go ahead and generate. If we don't have any relevant document left, then it does not mean anything to generate because we don't have context with us, which we can feed to a model, right? So we again exit with exception. Now we have two edges. Exit with exception is our last node. So it ends here. Generate is also our last node. So generate node. It's a dead end, generate nodes ends there. Two dead end nodes. And once you do this, this is on the right side is basically just the graphical representation of what we have done on the left end. So in the left end, we have coded it. In the right side, this is just the graphical representation of whatever you have done on the left side. Okay, great. Now let's quickly understand those two conditional edges which we are seeing here. First is the has relevant documents. Basically, we were using it here to see whether after grading the document to see whether we have relevant document or not. So it just check in the it takes the relevant document from the shared state documents field and it check whether we have a relevant document or not. If the length is 0 of this array, it means that all our documents were filtered out and none of them were relevant. So it returned a no. If we had relevant document, then it returned a yes. And that's what we are doing here. It has relevant documents. If it returns a yes, we generate. If no, we exit with exception. And if you see it clearly, has relevant document is used just after grading a document, right? And grading a document was doing nothing but running a for loop. So if grader response returned with a no at every case, we will never be able to push any of our document into the relevant document array, and this will be empty. And we will gonna update our shared state with an empty document. And that's what this conditional edge is checking. If the array of document was empty or not. If it was empty, then it means that all our relevant document got filtered out, or or none of our documents were relevant to software engineering and coding interview topic. And that's why it returned a no. And that's what we are listening here. If this conditional edge has relevant document returned a no, we have to exit with exception. If it's a yes, then we go ahead and generate from the LM model. Is the first conditional edge clear? If it is, then you can give me a yes. Okay, great. Now the second conditional edge, that is can continue. Can continue is also very simple. It just checks the answer. If the answer is exit, then it returns no. If it answer is not exit, if it is something else, then it returns a yes. Now we can again connect this. So can continue is used just after grading the question. And if we go back all our way and we see the grade question node, we used to grade this question, right, on the basis of whether it is relevant to software engineering and coding interview topic. If it was not relevant, we asked our LM model to return with an exit. That's what our prompt is telling the LM model to do. Yeah, return with an exit response. If the question is not relevant to SWE and coding interviews, return with an exit, otherwise return continue. So if LM model returned with an exit, the shared state answer got updated with an exit. And that's what we are testing here in the conditional edge. If the shared state answer was updated with an exit, it means that the question we have graded is not at all relevant with the software engineering coding interviews. And that's why we have to return a no. Otherwise, we return a yes and we go ahead with whatever we are doing. But if it's a no, then we have to exit with exception. And that's what we are listening here. If it's a yes, then we go ahead and retrieve the document and go ahead with generating our content from the LM model. But if it's a no, then we have to exit with exception. So is this clear? Does the entire picture is getting clear now? I hope it should be making sense now, because now we have connected a lot of dots. There is only one thing which is remaining. Can anyone tell me what we are left with? There is only one piece which you might want to see what it is there. Okay, there is some messages. Interface generate vector. Vector is there. Okay, I got it. Apart from vector, there is another thing. This is exit with exception. What is this exit with exception? So if you'll see, there is an add node line here which says exit with exception. We are adding a node here. So exit with exception is actually a node, which is exit with exception message. This needs to be implemented somewhere, right? So what is this doing? Let's see. So here, this is exit with exception message. What it is doing, it is simply saying that the question does not look relevant to software engineering coding interview domain. Please ask a relevant question. So we are asking our chatbot that, hey, if I'm asking some irrelevant question, then to return this response. So that is the end point of the chatbot. If anything goes south, then this is the response you can expect from the chatbot. So you are training that, okay, I'm not letting my LM model hallucinate. Even if it hallucinate, I'm gonna chime in and take things under control, and I'll make sure that my chatbot responds properly. What happens if actual answer returned by the rack prompt contains exit word with the, yeah, it will definitely work, but it will not look uh, decent, right? You don't want your chatbot to return an exit to the user. User will be like, okay, what does that mean? It's better to have a proper message there. So if it says your question does not look relevant, the user has this in mind, okay, this is a chatbot which is only trained for asking SWE and coding interview question. And if I'm asking anything irrelevant, then this is what I am getting in return. And that's how they will gonna understand, okay, it's better to ask question related to SWE and coding interview. So it's not an error from the LLM, it's an error from my end because I'm not making sense. My question is not making sense. Okay, great. So there is only one thing which is left here. I haven't added this in my slide. So I'm gonna just show you folks here what a vector store, what building a vector store looks like, because I can see you folks are like interested. So what I'm gonna do is that instead of this, I'm gonna share my entire screen so that you can see my VS Code implementation here. Okay, let's do that. Is the VS Code visible? So whatever I have shown you, I have implemented that and I have run that so that I can show you how it works, right? So this is a build vector store, the method which we used. This is the knowledge base URL. This is nothing but in constant, if you will see the knowledge base, these are the grader template which I have, which we discussed earlier. This is the knowledge base. So knowledge base holds technical interview handbook URLs. All of these URLs are related to system design, behavior, coding, and resume guide. And all. So it's basically everything is related to software engineering and coding interview prep. So that's how I am building my knowledge base. And if you will see my chatbot here, it's a VS Code editor. So if you will see my chatbot here, this is the URLs, which is basically the knowledge base URLs. And so for every URL, I'm using this Cheerio-based web-based loader to get the content. So it basically extracts whatever text content is there on the URL. So if it's an article or something, it's very helpful. So all of those are articles. So I'm getting those content here. I'm loading it, and I am so vector store, if anyone has read about vector store, they do not take the data directly. You have to split them into chunks. I have to decide their chunk size, and then you give it to the data. Then you give it to the vector store, right? So I have split the documents, and at the end, I have created the vector store with my document. So this is the document, and you have to pass the embeddings as well. So I have used a Hugging Face embedding to embed this data. Okay, does this code base make sense? This was the entire code base for building a vector store. What is a Hugging Face is a company, is a very famous company that builds machine learning models and internal models implementation. They have their own implementation for embeddings. They are open source actually. You can check them out. I can I this is posted on GitHub. So if you search me on GitHub, you will get the it's Lang. All the implementation will be there. So just let me know if this is okay. I'll move ahead and I'll just close this. Does that make sense? Okay, cool. Again, I'll move back and I'm gonna share my tab so that the content is visible. Okay, let's move ahead. So we saw the exception message. We saw how you will run it. It's a node application. So we have to have an index.js file and you have to create a server and you have to connect your logic with that. So a bit of development things you have to do. It's very easy to create. It's hardly a 5 to 10 line to create a server on node. And you can open your local host port and then you can hit the port to see your logic in action. Okay, so now exit with exception is done. This actually, I'm going to show you the video. It is nothing but what we have implemented here. What I have done extra is that I have created an index.js file, which I have beautified it to give it a look and feel of a chatbot. I'm asking question and you will see what it returns. So let's see. If you want me to zoom or magnify, I can do that, but let me know. Okay, I think this would be more clear. So what I'm doing is that I'm asking my LM model for tips to clear coding round interview. You see it's loading. So it's doing all the stuff which we did, which we created the node for. So since the question is relevant and the document is relevant, it will gonna generate. So you will see it is generating the answer. So some tips for clearing a coding round interview include practicing coding problems, familiarizing yourself with common algorithms and data structures, staying calm and focused during the interview. It is also helpful to review your coding solution and look for way to optimize them, blah, blah, blah. Right? Now what I'm gonna do is that I'm gonna ask an irrelevant question, like what's the weather? Let's see what it does. The model will not gonna hallucinate here. It will gonna follow your path. Now it exactly prints out the message which we have mentioned that the question does not look relevant to software engineering coding interview domain. Please ask a relevant question. So you now better understand that what has happened, right? When we asked an irrelevant question, in the grade question itself, the LM model returns with an exit response that what's a weather is not relevant to software engineering coding interview. and then they conditionalize responded with a no, and then we move to exit with exception, and exit with exception return the exception message. The question does not look relevant to software engineering coding interview domain. Please ask a relevant question. And that was it. That is how you build an entire chatbot web application on your local instance. So I hope this session was helpful. Now someone was asking me to maybe uh, is that person here the person who was asking to explain step one and step two. So step one was creating the LM model and step two was creating the question. So if you want me to provide more information, I am happy to. But yeah, since we are at the end of this session, I can see a lot of question around Coding Ninjas Bootcamp as well and how it can be helpful. So I would like to call out program expert from Coding Ninjas team. They are just going to take 10 more minutes of yours, and you are going to and they're going to explain how the bootcamp can be helpful in your career transition. So anyone from the bootcamp can come up now.